Glad that you're all here. Glad that you came to the talk. Thanks for coming in advance. Hopefully no more feedback. As she said, my name is Travis Sweet. I work as a senior technical support engineer at Confluent. So here's a little bit about me. I've been supporting Java applications for over 15 years. Last 5+ years, that has been at Confluent. And this year, my main focus has been Kafka Connect. That thing that we all love, right? Because it works. So taking a page out of Coach Prom's book, if I had theme music for my session, it would be We're Gonna Be All Right by Ty Tribbett. Earlier today, there was a session in here. I don't play instruments anymore, but Chris Egerton was playing a cello, so closest thing I can do to that is give you part of the chorus. We gon' be all right. So that's about it for the music part, but hey, I tried, right? All right. Another thing about me, I like fries and ice cream. You see the little asterisk? So that's important. That's gonna come back up. All right, and that's salted caramel, by the way, favorite flavor. All right, so today, here's our agenda. We're gonna do a high-level overview of Kafka Connect, talk about the purpose. Purpose is like how this talk came to be, lay some foundation. That's where the meat and potatoes are gonna happen. That's the most time we're gonna spend in that particular area. And then lastly, Kafka Connect has to do more than just run. Right? So, jumping right in. Here's my high-level overview of Kafka Connect. It's a wonderful piece of software, right? Computer software that allows users to get data from point A to point B. Kafka Connect and the brokers that it writes the data to, they sit in the middle, and it allows you to be able to connect to a source system without having to write any code, right? Bam, I'm connected to my database. For some reason, my company wants to move off MySQL, right? And we want to put everything in Postgres. How do I do that easily? Kafka Connect, there you go. Going to connect to MySQL, going to get the data produced to Kafka, then you're going to sync it or write it to its new destination over in Postgres. Sounds simple enough, right? High-level overview, that's what Kafka Connect is. Great, we're off to a great start. So that part is done. Now, purpose. How did this talk come to be? And remember, I just told you that Kafka Connect is a great piece of software, right? Show of hands. Everybody heard me? Thanks for participating. That makes this so much easier. So, 25-second video, please. Okay, now you're probably wondering, you just said it was a great piece of software, right? But remember, when I started, I said that I've been supporting Java applications for over 15 years. What they don't tell you is that out of the box, yes, it'll run, but is it configured to handle everything that you're going to throw at it out of the box? It's not. It's been that way since I started back in 2008, right? So, the house is like, it represents the Kafka Connect clusters that haven't been configured to be successful at scale. Make sense so far? Any similarities between the house and Kafka Connect that you can think of? Granted, it's the question that I'm just saying, think to yourself silently. I'm going to give the answers that I came up with, right? So if you're here for this session, it's very likely that your production Kafka Connect cluster is a vital part of your data pipeline. Okay. In the video, we saw that the house was completely built. The equivalent of that is you have Kafka Connect clusters that are running in production. So you've already built them. They're running, they exist, they're doing their jobs. Now, in the video, when you saw the house coming down and it crashed, that's when my name gets called. You file the support ticket, whether it's a P1, P2, P3. If it's a P1 and P2, when we get on the phone together, that's when the theme music plays. We gonna be all right. Like, it's a team effort. We're in this together. If you're running it and you're talking to me, we're on the same team. I want to figure out what's causing your issue, how to fix it, get you back up and running as quickly as possible. Not only me, have a lot of teammates that I work with, and we all work together to do that very thing. And just like the house, right? Houses are not cheap. Your Kafka Connect clusters are a substantial investment, right? And they probably represent hundreds of thousands of dollars in revenue in some way, shape, form, or fashion, because they are a critical part of your data pipeline. So, where, when, and why does this happen? Again, I'm talking to you from a support engineer perspective. It happens more often than not in production. I don't really care for that. Who likes to put out fires, right? Who wants to be running around figuring out how to fix it when everything's critical and everything's broken at the worst time? When does it happen? I've seen it happen after you had to add that one last connector that your external team needed because their use case or their deadline was right around the corner. And the day before, everything was working fine. You add the connector, now it's going sideways, right? Then another question to answer is like, why? Maybe, and I've seen this happen, you have more load or volume in production and you're not able to match that in your lower environments. So all the way up from POC to dev to staging to QA, you've tested to the best of your ability. You just can't generate the same volume, but you know that it works. You move over to production and it's 2x, 3x, 10x more data volume. And so that's how we get back to that slide, because you haven't even experienced what you're up against, and how would you know how to configure for it if you never experienced it? Well, you're here, so we're going to talk about some strategies to prevent this. And why can we prevent this? Hey, we're on the same team. Your problems are my problems. I want to do my best to solve your problems. You stay happy as customers, I stay happily employed, my wife is happy, my daughter's happy. See, we all win. So, what can you do to help with this? If you get anything out of this session, if there's another colleague, a person, another org in your company, another team, spread the word. Please tell them, okay? That's one of the things I asked. I'm probably gonna ask for some more things along the way, but that's at least one. Hope you're taking notes. So, first two things out of the way, right? Now we get into the meat and potatoes, so to speak, the foundation. So CPUs and cores, easy win, right? With the way that CPUs are being developed now, they're multi-core, multi-threaded, and so it's easy, right? Because you know you're gonna have lots of connectors, lots of tasks, so it just makes sense to have a multi-core system. Easy win. That part is easy. This part. This is the part where a lot of things happen. And again, it goes back to being able to kind of have an idea of how this works under the covers to be able to prepare for it. So today, memory's cheap, right? Doesn't cost a whole lot, not like it did back in the day. I'm not gonna get into how old I am, but it's not gonna cost as much as it did back in the day. But by show of hands, how many people have a smartphone? Quite a few of us. I have one, right? So if you have a smartphone and you have multiple connectors with multiple tasks running in production, your smartphone, whether it be an iPhone or Samsung Galaxy, it should not have more RAM than your production Kafka Connect cluster. Now I'm seeing some chuckles, but I've seen that happen. And so what happens in that case? It works up into a point. Then when it goes sideways, it really goes sideways. And we're in the trenches and we're trying to figure out why. Because now this is production. It's a little bit different for me because when I'm working on things, hey, I spin it up, spin it down. I don't have to tell anybody. If you're running it in production, then you have to say, wait, I can't just stop this thing, Travis. Like, I have other teams that might be impacted. there are a lot of more moving pieces and things that you have to be accountable for. So, what can we do to expand on this? Let's talk about how a JVM uses memory under the covers. And this is, of course, in respect to Kafka Connect, right? But you can apply these same strategies to any Java process. So, for JVM, or Java Virtual Machine, there are 3 memory areas. Metaspace memory area. Previously was called PermGen prior to Java 8. So what lives here? All the classes that make up the Kafka Connect framework, they go into Metaspace. All those connector plugins that you need, they go into Metaspace. And any SMTs, whether you wrote them or you downloaded them, they go to live there too. Native memory area. So an example of native memory and what the JVM uses that for, if there are any threads that are running under the covers, that's native memory. Now here's the one that just about everybody knows about, right? Java heap. So this one, you have to set an initial heap size and a max heap size. Sounds simple enough because the objects that are created by your Kafka Connect process, whether it be the connectors that are running, those objects go to live on a Java heap, and they live there until they're no longer needed, and then they're garbage collected. So anybody ever wondered, why the total memory footprint of a Java process is larger than just a Java heap? Yeah, I see some heads nodding. So, hints on the slides, right? It's the sum of the 3 memory areas that we just talked about. So what does that mean? Again, if you only have 4 gigs of RAM, you have to think about it in terms of, and I'm saying 4 gigs total, right? That 4 gigs, you have to split between those 3 memory areas. Doesn't sound so much like when you think about it in those terms, right? Because you got to account for the Java heap, you have to account for native memory, and you have to account for metaspace. Now, this part right here, this question, what does the JVM try to do in regards to garbage collection? This is a very, very important point because what it tries to do by design, we can use that to our advantage. So Travis, what do you mean? So glad you asked me. By design, the JVM will try to keep heap utilization between 40% and 70% of the Java heap. So looking at everything that we have on this slide, if we take this information, we can use that to determine when we should scale and if that scaling should be vertical or horizontal. Okay, everybody with me so far? Okay, I'll take that as a yes. I see some nods. So let's apply what we've learned so far. We have a Kafka Connect worker that's running on a machine with 16 gigabytes of RAM. That sounds decent, right? 16 gigs of RAM? Okay. How much RAM goes to Kafka Connect? These are questions that, like when you leave here, I want you to be thinking about it for when you're planning out your next phases, or even if you have time to go back before any type of code freezes, given the time of year that we're in, right? Because holidays are coming. But these are things I want you to be able to take back and hopefully get some changes in place. So then things can be a little bit better. So how much RAM goes to Kafka Connect? We can't forget about the OS. On average, the operating system itself is going to use about 2 gigs of RAM. So what does that mean for us? If the operating system is going to use about 2 gigs, then that means if we do some simple math, 16 minus 2, that's going to leave us with 14 gigs of RAM for Kafka Connect. And as a best practice, there are no other Confluent components running on this machine that exist that we're talking about now. Just Kafka Connect. So now we have to take those 14 gigabytes of RAM and we have to apply it to our 3 memory areas. Now, when we first talked about memory, I saved the Java heap for last. Now we're going to talk about it first. And there's a reason and some science behind it. So let's see. I'm going to take my initial heap size at 2 gigs and my maximum heap size at 6 gigs. And the reason that I'm doing this is because I already know that I'm going to be running more than one connector in production. So I already know that. So again, that's a minimum heap size of 2 gigs and a maximum heap size of 6. So what does that mean? That means that's going to leave us with 8 gigabytes of RAM to be used between the native memory area and the metaspace memory area. So again, simple math, the 14 gigabytes minus the 6 gigabytes leaves us with 8. Okay? So now, this key point from the previous slide, remember that the JVM's ideal heap utilization is 40% to 70% of the Java heap. So, how can we put all of this together? Given that we have a max heap size of 6 gigs, then that means that we have an ideal heap range of 2.4 gigabytes to 4.2 gigabytes. Now, let's stop right here for a second. I'm not telling you that if you're running lower than 2.4 or greater than 4.2, that the process is going to fail. That's not quite what I'm trying to get at. I'm saying that because we know that that's the ideal range, if we're running consistently under 2.4 gigabytes, right, then we can say, okay, I don't need a maximum heap of 6 because I'm trying to keep it or help the JVM stay within the ideal range, right? So then we can say we can come back and we can maybe shave off 1 or 2 gigabytes. And we're doing this in an iterative process, right? So we're not going to do 2 at first. We're going to do 1 and see how it behaves, then maybe 2, right? But when we do that, right, it's not that we lose that memory. That memory then goes back up to the other 2 memory areas. So instead of having 8 gigabytes, let's say we shave off 2. Instead of having 8 gigabytes that's going to be used between native memory and metaspace, now we have 10. Everybody follow so far? Make sense? Okay, now, this is the key part. If you go and you look at your clusters now, and you say, all right, this is my max heap size, and let's pretend that everybody has a max heap size of 16, right? For sake of argument, because that's what's on the slide, easier to follow. And you're consistently over the ideal top end of 4.2 gigabytes, consistently, right? Then that tells me, like if you were to file a ticket and you give me the data, you say, Travis, what do you think? Then I'm going to come back and tell you, okay, I'm going to explain everything that we've just talked about. And I'll say, based on this, it is now time to start thinking about how you're going to scale. Are you going to add another node, which will be horizontal, or is it going to be vertical? Now, for me, after being here for Current and listening to customers and thinking this through, I can't tell you the magic numbers like what you need for your environment. But given that it's in production and you have other responsibilities and you just can't like flip a switch and maybe get more memory, this is something that may be helpful. And just hear me out. If you have the ability, right, when you're going to go talk about to your internal teams, how much RAM do we want to give each node? After being here the last couple of days and thinking this through, I'm recommending at least 24 or 32 gigs. And here's why. You can start smaller, right? And then we already saw that if you don't have to have such a large Java heap size, then that memory still can be used. You may not use all of it, but what does that leave you with? If you're doing this kind of exercise, right, then you can say, oh, okay, I have room to grow. Then you can go back and follow the same pattern that we just did and say, I have more room on this particular node where I can do vertical scaling, and I don't necessarily have to add another node to the cluster right now. Because all of this, in essence, it's a balancing act. If you have an idea of how it works under the covers, then you're better equipped to balance all the things and all the moving pieces. So if you have 24 gigs, right? Then let's say we have a 12 gig max heap. So then we've taken off 2 for the OS, 12, that's 14. That leaves us 10 gigs to be split between the other memory areas. Everybody still with me? Okay, cool deal. So we've talked about the high level overview, the purpose, the foundation, and now we have to talk about Kafka Connect has to do more than just run. And what do I mean by that? Remember that video I showed you with the house? A lot of us have either houses or apartments, right? A lot of times we need insurance. Follow me? So the equivalent of that is when Kafka Connect has to do more than just run, it's doing the things that makes it easier when you call me, because I'm like your insurance, right? You're like, Travis, I've done everything that you told me when you did the talk, but this thing is down, I need help. This is so when I ask you for X, Y, and Z to get that information out, then you're in a better place to get it to me so I can help you. Because, I mean, have you ever tried to file an insurance claim? I mean, that has to be done like a certain way, right? And then if you do it a certain way, then you get a response a lot quicker. So there's some comparisons and some analogies that I'm trying to make. They're trying to make it a bit easier. So how do we investigate the Java heap utilization of our Kafka Connect worker? Great question. We have to enable verbose GC or verbose garbage collection and heap dump generation. So in Oracle-based JVMs, right, none of this is on by default. If you don't turn it on, it's not on. So you can have gone from POC all the way to prod. And if you don't have it on, things might be working. It's when things go sideways and you come to talk to me or one of my teammates and we need this data and you tell me, well, I can't turn it on. I have to go back and test it. Then after I test it and that passes, then I have to get it into prod. And so then we have a turnaround time of maybe like 3 to 5 days or maybe 2 weeks, depending. It varies, right? But you're still in that position of, I have this problem, how do I solve it? Again, I'm limited in what I can do to help if I can't get the data. So how do you go about turning on verbose GC and heap dump generation? Here's an example of what you have to turn on for Java 8, if that's what you're using. And the disclaimer at the bottom, the process, in this case, Kafka Connect, has to be able to write to the locations that are specified. And the location for the heap dump must be large enough to accommodate the file without it being truncated. So, quick point about the heap dump file. If your maximum Java heap size is 10 gigs, the heap dump file is going to be 10 gigs or around 10 gigs and maybe at times even a little bit bigger, just depending. But that gives you an example of like when you're thinking about, hey, where can I put this file in the event that I actually hit an out of memory error? Now, enabling verbose GC and heap dump generation for Java 11 and Java 17. Same disclaimer, but the configs look different, right? But those are what you need. And you can welcome to take pictures, but I have some links built in. So once that's available to you, just be able to go and click on the links and you'll have it. So that might be a little bit more user-friendly. All right. Now, you've turned on verbose GC, you turned on heap dump generation, and another point about heap dump. So why is that important? The different flavors of out-of-memory errors in Java. Some are heap, some are native. We could probably talk after this, and I can tell you wonderful stories about the different ones that I've seen in different situations working with different customers. But it's good to have it on in the event that you need it, especially in production, because if it is a Java heap out of memory error, and I can't get that, you can't provide that to me, then I can't tell you why it actually ran into the out of memory error. But the next thing is enabling JMX metrics for Kafka Connect. So these two things here, where should this be done? It should be done from the time you start your POC, to dev, to staging, to QA, to pre-prod, to production. Anytime you have Kafka Connect running, you should get in the habit of making sure that these things are on. Especially if you're in the particular scenario where you're like, hey, we don't have the type of load. Remember we talked about that earlier, the type of load in the lower environments that you have in production. So maybe by the time you get there, you have some idea of like, well, we figured out a way to kind of orchestrate or facilitate pseudo load in the lower environments so we can get a better handle of what we're facing in production. But if you have those turned on, right, then you can take a look at the data yourselves. If you can't figure it out, then again, we're here, file a ticket, and we got you. Team effort, day in, day out. So answer this one, should you enable all the above? I already gave you the answer. So like everybody that thinks you should enable all the above, I gave you the answer, remember? Show of hands. Thank you, thank you. I mean, I'm trying to get you all to participate. It makes this so much easier. Okay, so next part. Do your Kafka Connect logs show the specific connector and the specific task in the logs? This is vitally important if you're coming to me or someone on my team with the issue. Have you ever tried to debug one of these and you don't know the exact connector and the tasks that's causing the problem? I mean, again, I have my support hat on. These are all things that I've seen, whether it's the ticket that I own, that I'm working, or one of my colleagues. 99.9% of the time, if this information is not there, we're going to be very limited in what we can do to help you resolve your problem because we don't know. Why don't we know? Well, I need to show you the examples. And so the examples, we're going to see one where we have map diagnostic context, MDC for short, logging enabled, and one where we do not. Again, this should be done in all of your environments. So this is what the logging looks like without MDC enabled. Yeah, I can see it there, I can see it here, I can see it there. No matter which way I look, I don't know which specific connector is logging this, nor do I know the task. Because a lot of times you might have you might have more than one type of connector running, for sure, but sometimes you might have more than one JDBC connector running, but they just have different names. But even though they have different names, without MDC enabled, we don't know who's doing what. So this is what it looks like with it enabled. We can see the name of the connector, and we can see the name of the specific task. All of this is crucial when you're trying to investigate and debug problems. So, which Connect protocol should you be using in your environment? By default, now the Connect protocol is sessioned. But should you be using session or should you be using eager? It really depends. So I'm asked that question, but in order for me to give you an answer, I have to ask another question. Even though they say, don't answer a question with a question. It works, at least for this use case. So are you running Replicator as a connector? By show of hands, is there anybody here that's running Replicator as a connector? And okay, wait, keep your hands up just for a second. Do those Replicator connectors run in and if this is true, leave your hand up. Do they run in a Kafka Connect cluster that has other types of connectors also running? Okay. If you are doing that and the default protocol of session is being used, that creates a bit of a problem. What do you mean, Travis? Why is that a problem? So, it's a particular problem because there's a limitation for Replicator as of, I think it was back in version 5.3.0, that if you do not use the eager protocol, right, and you use session, there's a chance of Replicator producing duplicates. Now, duplicates can be bad. Why? Because you might want stuff exactly once or only one time. You don't want some record that's maybe some type of financial data or something like that to exist twice. And you want stuff to be just like it was when it came in on the source cluster, right? So how can you get out of this? You may have to file a support ticket with us, but here's what I recommend at a high level. If you're doing this now and you want to take this completely off the board, right, the chance of having duplicates due to this, then what a good thing to do is to just spin up a new Connect cluster, set the protocol to eager, give it its own internal topics and group ID, and let all the replicators that are running as connectors, let them live there. Right? So if you've isolated it and then those live there, they can use the eager protocol. And my team lead did a talk earlier this year at Kafka Summit in London that goes over the Connect protocols. And I'm giving him a plug because remember I told you I like fries and ice cream? So I'm giving him that plug so when I go back to work, I can have to tell him he has to give me all the fries and ice cream that I want because I plugged him in my talk. That sounds fair, right? Yeah, that works. So, this point right here, Java runtime versus Java development environment. How many people are running just on the JRE and not the full JDK? Okay, so I saw one hand. Will it run? Yes. If I need you to give me full thread dumps or things like that, it's not as easy. So it's easier to run it on the full JDK when we go to talk about full thread dumps, GMap, getting data out of it, right, than versus just running on the JRE. If you have to run on the JRE due to some internal requirement, find me after the talk and let's have a quick chat about like what we can do to kind of get you in the best place possible with that requirement. Fair enough? So, here's everything that we've done in our agenda. As far as I can tell, I've covered all of those, and that covered everything that I said that I would talk about when I wrote the summary for this particular talk. Looking at the timer, we have about 11 minutes left and some change. So, this is where you can find me. I'm still going to say Twitter because that just makes more sense in my head. So Twitter and LinkedIn, that's where you can find me. If you have other questions that you don't get to ask me today, or you have thoughts later on, here are the links that are built into the presentation. So once this is available to you, I've already checked them. I guarantee that they work. When you click on them, it's going to take you where you're supposed to go. So at this time, questions, if there are any.